In this video, we will solve a problem on profit maximization in case of monopolistic competition. The question is, suppose that a monopolistic competitive market consists of 11 firms with the following identical demand and cost functions. That is, P subscript K is equal to 150 minus twice QK minus 0.2. Summation of I is equal to 1 up to 11. I is not equal to K. Summation of QI. And CK is equal to 0.5 QK cube minus 20 QK square plus 270 QK. K is equal to 1 to up to 11. Okay, we have to determine the maximum profit and the corresponding price and quantity for a representative firm, assuming that the number of firms in the industry does not change. Okay, so let me try to solve this question. A little bit of caveat here. I am solving this question. I don't know whether the method is correct or not. Yeah, you people decide whether I have done it correctly or not. Okay, so a little bit of disclaimer was necessary for this question. So we are being given the demand function for the kth firm is, that is Pk is equal to 150 minus twice Qk minus 0.2 summation of I is equal to 1 to 11, but I is not equal to K summation of Qi here. Okay, this is the inverse demand function for kth firm. Here we are being told that we have the identical demand and cost functions. So let's take, and in case of monopolistic competition, we know that profit maximization occurs where marginal revenue is equal to the marginal cost. Okay, so profit maximization will require that we equate the marginal revenue of kth firm with the marginal cost of the kth firm. This will be the profit maximizing condition in case of monopolistic competition. So let's take a representative firm. Let's take K is equal to 1. Okay, let us say K is equal to 1. When K is equal to 1, that means P1 will be equal to 150 minus twice Q1 minus 0.2. Okay, we have to sum from I is equal to 11, but I is not equal to K. Since we have taken K is equal to 1, okay, so we cannot write, since we have to sum Qi here, so we have to write here Q2 plus Q3 plus so on up to Q11. Okay, remember this point here. We have to sum up Qi's. Okay, I is equal to 1, but I cannot be equal to K. Since K is equal to 1, we have to drop out the first Q1 here. Okay, this is the inverse demand function. Now what will be the total revenue of firm 1? That will be equal to P1 into Q1. Okay, total revenue is equal to price into output. So can we write it in this fashion? 150 minus twice Q1 minus 0. And let me write it here like this. We have 0.2 Q2 plus Q3 plus so on up to Q11. Okay, to this we multiply by Q1. Okay, that gives us total revenue of firm 1 will be equal to 150 Q1 is multiplied minus twice Q1 square. Okay, then we have minus 0.2. Okay, 0.2 Q1 Q2, so we have 0.2 Q1 Q2, then we have again minus 0.3 Q1 Q3 minus so on up to minus 0. We have 0.2 here, 0.2 Q11 Q1 or Q1 Q11. We have multiplied Q1 to each of these terms. That is 0.2 times Q1 into Q2, minus into plus is plus 0.2 0.2 times Q1 into Q3, so and so on up to 0.2 Q11 Q1. Okay, this is the total revenue function of firm, what we call firm 1 here. So let me see what is this is the space that I can use up to this now. Okay, so what will be then the marginal revenue? So marginal revenue of firm 1 will be equal to the derivative of total revenue function with respect to Q1. Okay, so derivative of Q1 in the first term is 1, so we are left with 150 minus derivative of Q1 square is twice Q1, so 2 into 2 is 4 Q1. Okay, so and in the same way minus we have 0.2 derivative of Q1 is here 1, so we are left with Q2 minus then again we have derivative of Q1 is again 1, so we are left with 0.2 Q3 minus so on up to derivative of Q1 in this term will be 1, so we are left with 0.2 Q11. Okay, so let's write it again. So we have 150 minus 4 Q1 minus, and let us write 0.2, let us take 0.2 common, so we are left with Q2 plus Q3 plus so on up to Q11. So can I write it like this? Marginal revenue of firm 1 will be equal to 150 minus 4 Q1 minus 0.2. We are being told that we have 11 firms and they have the identical cost functions. Okay, if we have identical cost functions, can I write Q1 is equal to, that is Q2, rather Q1 will output produced by firm 1 will be equal to output produced by firm 2, which will be equal to output produced by firm 3, and so on up to which will be equal to output produced by 11th firm. So can I write in this place Q2 is Q1 and in this Q3 is Q1, so on up to in place of Q11 also we have Q1, which means marginal revenue of firm 1 will be equal to 150 minus 4 Q1 minus 0.2. So we have Q1 up to 10 times because we have Q2, Q3 up to 11. So these will be 11 times. I have to write it like this. Sorry, it will be up to 10 times. 10 times here. So which will be equal to here 10 Q1. So marginal revenue of firm 1 will be equal to 150 minus 4 Q1 minus 0.2 into 10 is 2 Q1, which will be equal to marginal revenue of firm 1 will be equal to 150 minus 6 Q1. This is the marginal revenue function of our representative firm, which is firm 1. Now we need to find out the marginal cost. So CK is equal to this very stuff. And let me see, your joy. I know. So let me write it here. We have the cost function is CK is equal to 0.5 QK cube. So let me write it here again. I don't have the space here. So let's write it here. So CK is equal to 0.5 QK cube minus 20 QK square plus 270 QK. This is the cost function of the kth firm. So let's find out the cost function of firm 1. That will be equal to C1 will be equal to, in place of K we have 1 as the subscript, 0.5 Q1 square, sorry, Q1 cube minus 20 Q1 square plus 270. Okay, so we have 270 here. In place of, here we have K, here we have Q1. Okay, this is the total cost function of firm 1. That is marginal cost of firm 1 will be the derivative of cost function of firm 1 with respect to output, that is Q1. So derivative of Q1 q will be equal to 3 will become a coefficient, so we have 3 into 0.5 and exponent of q1 will be subtracted by 1, it will become square minus in the second term derivative of q1 square is twice q1, so we'll get 2 into 20 into q1 exponent is subtracted by 1, so we will get exponent is 1 plus derivative of q1 in the last term is 1, so we are left with 270. So let's rewrite it again. So marginal cost of furrow 1 will be equal to, this comes out to be 1.5, so we have 1.5, or let's write it 1.5 go panda divided by the 5 2s are 5 3s are, so 3 upon 2 q1 square minus 2 into 20 is 40, q1 plus 270. This is the marginal cost of firm 1. Now we need to, profit maximization requires that we equate marginal revenue of the firm 1 with the marginal cost of firm 1. Okay, so profit maximization requires marginal revenue of firm 1 should be equal to the marginal cost of firm 1. Marginal revenue is this very function, marginal cost is this very function. Let's first write the marginal cost for that is 3 upon 2 q1 square minus 40 q1 plus 270 should be equal to the marginal revenue. This is the marginal cost. Let's equate it with the marginal revenue, which is 150 minus 6 q1 here. Okay, doing this, what will we get? So let us solve it here. This equation first, we have 3 upon 2 q1 square minus 40 q1 plus 270, transposing these terms, so it becomes minus 150, this becomes plus 6 q1, which will be equal to 0. So we have minus 40 plus 6, minus 40 plus 6 go minus 36. Okay, so we get 3 upon 2 q1 square minus 36 q1 दोनों हाथों सतन वालों it will be plus here, 0 goes 0, सतन पांच z, we get here 120. Okay, let us equate it 0. Let's write it in the standard form of quadratic equation. That means we have to get rid of the coefficient of q1 square. So what will we do? Let us multiply both sides by 2 upon 3. Okay, so let's multiply both sides by 2 upon 3. Here also we multiply by 2 upon 3. So what will happen? We will get 2 upon 3 into 3 upon 2 q1 square minus, then we will get 2 upon 3 into 36 q1 then plus 2 upon 3 into 120 is equal to, this will be equal to 0. So these terms gets cancelled, we are left with q1 square minus, here we will get 3 1s are 3 12s are 36 bath bag is 2, we get 24 q1 plus 3 1s are 3 4s are 12, 3 zeros are 0, 40 into 2 is 3 4s are 12. 40 into 2, 4 2s are 8, it is equal to 80 and it is equal to 0. So this became a standard quadratic equation when we solve this. Now let me mutav that. So solving this, we got this result, that is q1 square minus 24 q1 plus 80 is equal to 0. Since this is a quadratic equation, we can use the factorization method. That is, we should get the sum of two numbers. Circle the banal local. We should get the sum of two numbers equal to the coefficient of the middle term, which is equal to minus 24, and the product of same two numbers should be equal to the constant term, which is equal to 80. Okay, basic mathematics here. No rocket science. Okay, let us try and guess. Can I write minus 24? If I write here minus 20 minus 4, so minus 20 and minus 4 is minus 24, minus 20 into minus 4, it will be equal to 80. So can I write q1 square in place of this term? Can I write it like this, minus 24 q1, then we have minus 4 q1 In place of 80, can I write minus 20 and minus 4 is in the multiplication order, which is equal to 0. Then we factor out the terms. Okay, so let me factor this out. I will drop this stuff here then, because I don't have, you know, luxury of having more space. So let's take q1 common. Q1, if I take common in the first two terms, I will be left with q1 minus, sorry, here it should be 20. Okay, at 20, okay, minus 20. Okay, if I take q1 common, I will be left with this. Let's take minus 4 common in the last two terms. We will be left with q1 minus 20, which is equal to 0. Which, let's take q1 minus 20 common. We will be left with q1 minus 4, which will be equal to 0. It implies either q1 minus 20 is equal to 0 or q1 minus 4 is equal to 0, which is q1 is equal to 20 and q1 is equal to 4. Okay, so we got two values of output here. Okay, आगे से कम से कम negative. So since no one is negative, we cannot rule out the negative quantity. Both are positive. Now we have to check the second order condition here. So when we solve this, we got two values. q1 is equal to 4 and q1 is equal to 20. Okay, first order condition for profit maximization was that we equate marginal revenue with the marginal cost. Now since we got the two values for q and none of them is, you know, negative, so that we could have ruled out the negative quantity, we have to check out the second order condition for profit maximization. So let me draw the simple graph here. Okay, let us say we have the output on the horizontal axis and your okay, let us take the price on the vertical axis and all other stuff, that is marginal revenue, marginal whatever we have. Okay, so we have downward sloping demand function that we got it done as this is the downward sloping demand function like this. Okay, but we have a quadratic marginal cost function. Okay, so our cost function will in fact look like this, quadratic. This is our marginal cost function. Okay, let me see if I am in my awqat. Now I am in my limiters. Okay, so at 2 points, profit maximization condition, first order condition, gave us two values of output where profit is maximized, when q1 is equal to 4 and when q1 is equal to 20. Okay, so marginal cost function, in fact here it is a quadratic one, so it will look like u-shaped. I'm not sure how much, what kind of u, but so first order condition was used to find out the values of q1 and q1, and we got two values for q1. Now second order condition for profit maximization requires, so let me write it here. First order condition tells us that we equate marginal revenue with the marginal cost of firm 1. So we got two values. Now second order condition is used for profit maximization, that is the slope of, and how do I write it here, slope of marginal revenue at the critical points should be, what can I say, greater than. Okay, it should be greater than the slope of marginal cost function. Okay, so first order condition is met, we are done with this, but this first order condition gave us two values for output values, or rather profit maximizing values. Now to check out as which of these two in fact maximizes the profit, we have to check out the second order condition. So second order condition tells us that the slope of the marginal revenue function should be less than the slope of the marginal cost function. So what is the slope of marginal revenue function? That is simply the second derivative of marginal revenue function, that is d square mr1 with respect to dq1, and we evaluate it at the critical points. So let's take the second. Good guys, this is the first derivative. So when we take the derivative of this function again with respect to q1, it will give us the second derivative, which comes out to be here minus 6. Similarly, the slope of marginal cost function, let us find out the slope of marginal cost function. That is the second derivative of marginal cost function with respect to q1. Okay, so derivative of this function again with respect to q1, we will get the coefficient derivative of q1 square is 2q, so we will get 3 upon 2 times 2q1 minus derivative of q1 in the second term is 1, so we are left with 40, and derivative of a constant is equal to 0, so 2 and 2 gets cancelled, so we are left with 3 2s are 6, so we get 3q1 minus 40. Okay, this is the slope of the marginal cost function. Now second order condition tells us that the slope of the marginal cost function, when we evaluate it at the critical points, it should be greater than the slope of the marginal revenue function. Okay, so what is the slope of marginal revenue function? We got it equal to 6. Okay, so when q is equal to 4, what will be the d square mc1 upon dq1? When q is equal to 4, when we evaluate the second derivative at the critical point, which we got here is 4, one of this, let us check. So we have 3 into 4 in place of q minus 40, so we will get 3 4s are 12, which comes out to be minus 36. Okay, so slope when q1 is equal to 4, it comes out to be 36, minus 36. But since slope of marginal revenue function, slope of marginal revenue function is minus 6 and slope of marginal cost function is minus 36, since minus 36 is less than minus 6, so this cannot be the optimal point. Let us take q1 is equal to 20. Okay, when q1 is equal to 20, let's evaluate the slope at the second order condition, so that is d square mc1 upon dq1. When q is equal to 20, we will get 3 in place of q1, we have 20 minus 40, so 20s are 60 minus 40, so when q1 is equal to certain SIG, it comes out to be 20, so we get here 20. When q1 is equal to 20, okay, when q1 is equal to 20, slope of the marginal cost function is greater than the marginal revenue function, as we have seen here. So we can say that profit will be maximized when q1 is equal to 20. Okay, if you are wondering why it got messy, I don't know why it got so much messy. Simple thing was that is first order condition for profit maximization requires, let us say we have the marginal revenue, this is the marginal cost function, that marginal revenue should be equal to the marginal cost. Okay, we have to check out the second order condition only because we got the two values for the output where profit was maximized. So to check out that very thing, we have to find out which of these two output levels will in fact maximize profit, and in this case it happens when q1 is equal to q2, because second order condition tells us the slope of marginal revenue function should be less than the slope of the marginal cost function, and it happens only when q is equal to 20, when we take the second derivative of both marginal revenue and marginal cost functions. So when q is equal to 20, slope of the marginal cost function is greater than the marginal revenue function, and in this case it means that since these 2 points are here, so when marginal revenue and marginal cost functions what we call intersect each other, at the point of intersection the marginal cost should be increasing. That is the essence of saying the second order derivative of the marginal revenue function should be less than the marginal cost function. Okay, so at the intersecting points the marginal cost should be increasing. That is why we are saying that the slope of the marginal cost function should be greater than the slope of the marginal revenue function. Okay, so I hope I am done with this. Now we need to solve for other stuff. So we got profit is maximized. So profit is maximized when Q1 is equal to 20, okay, because we have seen it here. Now we need to find out the what I need to find then. Now we need to find out the profit maximizing profit. So you can find out the profit of firm 1 will be equal to P1 into Q1 minus C1, okay. So we also need to find out the what we call profit function. Rather, we need to find out the inverse demand function. So let's write what will be then what we call the market price. Profit maximizing price will be equal to 150 minus twice Q1 minus 0.2 times 10 times Q1, okay. I guess it will be like this. So P1 will be equal to 150 minus twice Q1 is 20 minus 0.2 into 10 is twice. I guess it is equal to let us write it here, 2 upon 10 into 10 into 20, okay. Why I am writing this? So we have to put Q1 is equal to 20 in this equation. So P1 will be equal to, when you solve this, so you will get the profit maximizing level of price will be equal to 70, okay. Now you can find out the profit. So as we know, profit is equal to P1 into Q1. So P1 is 20, Q1 is 70, so 20 into 70 minus the cost function, okay. Cost function is this, so we can write 0.5 Q1. So we need to write Q1 here and Q1 here now, okay, to find out. So that will be equal to 20 square, then we have plus 270 into 20. When you solve, we will get the profit for representative firm equal to 3600, okay. I have solved it some stuff here earlier, okay. So this is how do we solve this kind of question. So for a monopolistic competition, we were given the identical demand and cost functions. We first to find out the marginal revenue and marginal cost functions, then we equate them with each other. So we got the profit maximizing level of output as 20 and profit maximizing level of price as 70. So I request you, please cross check you know what I can say, please cross check the solution with your friends whether I have done it correctly or not, okay. So the caveat still remains that I have solved it as I understand the question. So it is up to your discretion whether I have done it correctly or not. You check it with yourself, okay. I hope I make myself clear in this video. Thank you.